Hello guys, in today's class we shall discuss third chapter of yours module 1, that is overcurrent protection. At the first we have introduction. We know that a protective relay operates only when the load current exceeds certain preset value, and such type of relay is called as an overcurrent relay. Relay operates only when the value of preset current is above. So it is known as pickup value. Pickup value is that when your relay starts to operate. It operates only when the value exceeds the preset current value. So the name pickup value. Overcurrent relay offers you the cheapest as well as simplest form of protection. It also used in the distribution lines, large motors, power equipments, industrial systems, etc. So even where overcurrent relays are also used in some sub-transmission lines. This scheme incorporates overcurrent relays for the protection of the power system, is known as overcurrent protection. A overprotection scheme may include one or more overcurrent relays. Here at the present we know that electromechanical relays are widely used for the overcurrent protection. We also discussed the induction type construction is commonly used. So with the development of numerical relays based on microprocessors as well as microcontrollers, it is gaining trend to use numerical overcurrent relays when compared to that of traditional relays, that is electromechanical relays. Okay, so your numerical overcurrent relays are finding advantages as we have already discussed this earlier class how it is good when compared to that of electromechanical relays. So it is gaining wider attraction. Now let's see the next topic, that is time current characteristics. We have wide variety of time current characteristics which will be seen in the coming classes for overcurrent relays. At the first we have definite time overcurrent relay. As the name itself indicating, such relay operates after predetermined time. Only after definite time this relay operates irrespective of the magnitude of the current above the pickup value. So here the operating time is constant. So the desired defining operating time can be set with the help of intentional delay mechanism which is available in the relay. So you can set any defined operating time for the overcurrent relay to operate. So such relay operates only after certain time is crossed, that is definite time is crossed. Okay, so this is what we have with definite time overcurrent relay. Let us see the second one. Okay, anyhow the figure is dealt in the next page, we shall see that. So second one is instantaneous overcurrent relay. Here again name itself indicating this relay operates in a definite time when the current exceeds pickup value. So very next, when your current is exceeding the pickup value already told you what pickup value means. The pickup value is a preset value at which your relay will start to operate. So when the current exceeds the pickup value, this overcurrent relay will operate very instantaneously. Very next moment this relay will operate. Here also the operating time is constant irrespective of the magnitude of the current as shown in the figure below. Again here there is no such option like to introduce intentional time delay. It operates in 0.1 second or even less, so fast. Sometimes the term like high set or high speed is also suitable for such relays to name which has operating time less than 0.1 second. Okay, so such relay is very instantaneous As soon as the current exceeds the pickup value, the relay will start to operate. It's not like it will wait for certain period of time. So that's why the name instantaneous overcurrent relay. Third one is inverse time overcurrent relay. Here, this overcurrent relay operates when the current exceeds the pickup value. Obviously, it is true for all. But here, the operating time depends on the magnitude of the operating current. Before in our cases, that is in two cases, your definite time as well as instantaneous overcurrent relay, their operating time was constant irrespective of the magnitude of the operating current. But here the operating time is depending on the magnitude of the operating current. Here the name inverse is rightly told because the operating time is inversely proportional to the current. As current increases, the operating time of such relay will decrease. Okay, which is shown in the curve B. That is inverse time characteristic. More the fault current, lesser the time taken by the relay to operate, or you can say trip. The first curve A is with respect to definite time overcurrent relay as well as instantaneous overcurrent relay. You can see whenever the pickup value has crossed, the relay is operating, it start to operate for definite time as well as instantaneous overcurrent relay. That is what the difference between definite time instantaneous overcurrent relay as well as inverse time overcurrent relay. This depends on the magnitude of the overcurrent, that is operating current, whereas your definite time as well as instantaneous doesn't depend upon the magnitude of the operating current. Okay, hope this graph you understood. The x-axis is actuating quantity and the y-axis is operating time. So actuating quantity may be in terms of current or something. So whenever pickup value has crossed, your relay has started to operate. For the B figure, you can see as the it is taking very less time when compared to that of A figure. The curve is almost less curve when compared to this curve A. Okay, hope you understood this inverse time overcurrent relay. It depends on the magnitude of the operating current. The first two doesn't depend upon the magnitude of the operating current. Now let us see the fourth one, that is inverse definite minimum time overcurrent relay, or also it is called as IDMT relay. Here again name is indicating it has got two characteristics in it. First characteristic is inverse time overcurrent relay and the second one is definite time overcurrent relay. So it acts like inverse time current relay at the lower values of the fault current, the first one like I said, and it acts like a definite time overcurrent at higher values of the fault current. So generally if the plug setting multiplier is below 10, then it acts like inverse time characteristic. If the plug setting multiplier is between, that is above 10 and below 20, then it acts like definite time characteristic, where the characteristic become straight line towards the definite time characteristic like we have seen in your earlier figure. In the coming figure, we shall see the characteristic of IDMT relay along with the other characteristics. So IDMT relay is widely used for the protection of the distribution lines. Such relays also give the provision of current as well as time settings. Next one is very inverse time overcurrent relay. Again here name is indicating it is nothing but a normal inverse time overcurrent relay, but it has got very intense characteristics than that of your normal inverse relay or your IDMT relay. So its time characteristic lies in between that of IDMT as well as extremely inverse characteristic relay, which we are going to discuss in the coming section. We discuss IDMT, right? So now in the next section we will be discussing extremely inverse characteristic with respect to overcurrent relay. Hence such type of relay is used only when your IDMT relay fails to achieve any good selectivity. So what selectivity actually mean? It's nothing but its ability of relay to point the fault where it occurs and select the nearest circuit breaker in the system to trip the fault as soon as possible. No damage is made to the system. So the recommended standard time characteristic of such relay is given by T is equal to 13.5 divided by I minus 1. So this is the standard relation which you need to remember, or general expression for time current characteristic for overcurrent relay is given by T is equal to K divided by I raised to n minus 1, where n is the value of inverse characteristic, very inverse characteristic, and the value may lie between 1.02 to 2. 1.02 to 2. So very inverse time current relay are recommended for the cases where there is a substantial reduction or decrease in the fault current, as we know that distance from the power source increases. They are particularly effective when ground faults because of their steep characteristics. Steep characteristic means what? State characteristic. So that's why it is called as very inverse time over current relay. So wherever we require the steep characteristics, such type of relay is used, and whenever IDMT relay fails, we go through the very inverse time over current relay. So make sure to remember those two expressions which may help while solving problems. The next we have extremely inverse time over current relay. See, again this is again one step ahead of your very inverse time over current relay. So here such relays, that is inverse time over current relay, has time current characteristic even more inverse than very inverse as well as IDMT relays, like I told you earlier. Whenever your IDMT as well as very inverse time over current relay fails, then we are going to use or select extremely inverse time over current relay. From the figure you can see that extremely inverse time over current relay is even more steeper when compared to very inverse time over current relay as well as IDMT relay over current relay. Yes or not? You can see it is more steep, more down when compared to this. Yes? Whenever it comes for the protection of the machines against overheating, you can choose extremely inverse relay, as it is governed by the law I square T is equal to K. So such relays are used for the protection of alternators, power transformers, earthing transformers, expensive cables, railway trolley wires, etc. And even whenever your large alternators are overloaded, or if they are unbalanced, load is put on. So due to this, what happens? The rotors may get overheated. So if the fault remains for longer period on system, then in such a case, extremely inverse relay can be made in use with the help of negative sequence network. Thus, by adjusting time as well as current, a suitable characteristic of the relay can be made in use for the protection of any machine. Your relay should not operate for any change in the momentarily change in the overloads. It must see that a sustained short circuit has occurred in the system. So in that case, your IDMT relay as well as your very inverse relay failed to operate. So in that case, we need to make use of extremely inverse overcurrent relay. Say whenever after long outage, say your circuit breaker is again reclosed, again power is restored. So due to this, what happens? A heavy inrush current starts to flow in the system, which is incomparable with the fault current. Means it acts like a fault current in the magnitude, but your IDMT relay should be able to distinguish such high inrush current with respect to the fault current, as we know that this inrush current is heavily decaying. So in that case, your relay should not trip. Okay, so thus by making use of extremely inverse relay, it will able to distinguish the fault current as well as heavy inrush current, thus by not tripping the circuit again.